this is very much about the past rather than the future, but we don't understand the past. We don't know how we've got to where we are. So I've been a while putting this together for other groups as well, but specifically this is I've tailored it for the PWI. So okay, it's a good start. Yeah. What I'm going to do tonight, it falls into 4 sections, but some of them are quite short. So I'm just going to talk about where we started off. And it's very appropriate and it's good to be able to do this in September, because in 17 days' time, it will be the day, the 200th anniversary to the day of the opening of the Stockton and Darlington Railway, which was really, in many ways, the first modern railway and where we've evolved from. So we could just touch on that. We're going to spend quite a bit of time talking about how things developed from that through the 19th century, because it was an incredible period of experimentation and trying different solutions to permanent way. I'm going to touch very briefly on what happened then through the 20th century, but not spending too much time on that. And then couldn't leave the subject without talking about the nature of permanent way work and plate layers, track staff, because I think that's very important. It's not just about things, it's about the people. And I'm very keen that we touch on that. So there we are. Very famous painting from the opening day of the Stockton and Darlington Railway on the 27th of September 1825. With the opening train crossing the Skerne Bridge. Now, the Skerne Bridge it is quite amazing because it is the oldest railway bridge that's been in continuous service. It still carries the line to Bishop Auckland from Darlington. So it's a very, very busy railway, and that bridge is still standing and in everyday service. The week after the opening of the Stockton and Darlington, the Durham County Advertiser called the railway that stupendous work. And it's perhaps difficult to get our heads around what a change that introduced to people who are only used to horses, basically, and going at a few miles an hour. So it was a stupendous work, and I will show you where it took us to. George Stephenson, painting on the right, was instrumental in the development of the Stockton and Darlington, and is forever associated with it. We might think of him as one of the pioneers of the steam locomotive, and indeed he was, but he was also a very accomplished track engineer. And in fact, Stephenson said that locomotives and track were like a married couple. So the wheel-rail interface is nothing new, and Stephenson understood it very well. It was Stephenson who made sure that the Stockton and Darlington Railway was not just another horse-drawn wagonway. And it's interesting that the seal of the company does indeed show a horse-drawn wagonway. And that's what it was going to be. And there were many of them already when the Stockton and Darlington came into being, all over the coalfields of Northumberland. It's worth noting that the motto of the Stockton and Darlington Railway Company actually means private risk, public utility. So again, perhaps a forerunner of more recent times in our industry. So what I'm going to try and explain very briefly, hopefully, this evening is how we got from here, the opening of the Stockton and Darlington Railway, famous painting by Terence Cuneo, to the track we know and understand and we find all over the network today. 200 years of development. I'm going to suggest that if George Stephenson were to time travel and materialize in the year we are now in 2025, he would probably understand very well the track form. It wouldn't be so strange to him. He would probably struggle a bit more to understand rolling stock. But I'm sure it'd be clearly interested. But that is not to say that the track form has not evolved and changed. It has, and we'll see that as we go through the various iterations. But I think Stephenson would very quickly understand it. In preparing for tonight, I've used a number of sources. The book on the left, many of you I'm sure know it, Andrew Dow's tome. It's a masterpiece in terms of the history of British railway track, and the amount of detail in there is amazing, very well researched. I'm also going to use a few pictures which I've been allowed to use from the National Collection. There are about 2,000 items, permanent way items, rail sections, chairs, base plates, and so on, that form part of the National Collection, the Science Museum group. And I'm going to use some pictures of those to illustrate the changes as we've gone. So that was one or two sources. I've also delved into this website, the Railways Archive, which has fascinating history of railway accidents. And you can select through drop-down menus, and you can look at records of accidents. So I've been looking at a number of permanent way caused accidents, broken rails, and so on. And there are a few case studies as we go through. And I've spent a lot of time looking at the PWI journal, delving back into some of the very earliest papers. And that is an absolutely fascinating exercise. And it shines a light on a lot of our history. You see some incredible debates. You see some very interesting characters, often with quite strong views. You see a lot of almost argument in some of the section meetings. And it's also very interesting just to get the feel for what the PWI was like in its early days. And looking back at those early journals, there was a tremendous cross-section of subject matter that was covered. And it wasn't just about track, it was about structures. There was a huge amount of insight on what was going on in railways overseas in the late 19th century. Papers from India and Africa, all over the world, and a lot as well from the United States. So it was very, very diverse range, and that's made some fascinating insight as well. And I'm going to quote a few things from those papers. So where did it begin? Well, it began actually a long time before 1825. There were records, I think, of wooden plankways going back into the 1500s associated with mines, and some very rudimentary wagons and trucks like this with wooden wheels on wooden rails were very well known in Europe. And some of those early trackways, wagonways, have been discovered and conserved. Particularly this one, which was at on the Tyne. It's called the Willington Tramway, and it was uncovered just in 2013, and parts of this have been conserved. The main line was actually up here. This is in a depression, this track. As you see, it's got a very interesting stone base and that would have been for the horses to have a smooth footing. And that would have probably been a kind of a sump to dry or to wash the wagon wheels, and maybe to cool the wagon wheels and the brakes, having come downhill to the port on the Tyne, bearing their materials from the collieries. And so what's interesting as well, you might notice the wooden rails there are two. And this was a device that was used on some of the early wagonways, so that it was quite easy, because obviously the wear was quite considerable. So it would have been quite easy to replace the top beam without disturbing the structure of the track. And that was quite an interesting innovation. So as I say, wooden wagonways were very well known, very common, particularly in the northeast, in the mining areas, taking the coal out to the ports. And I came across this record of one such wagonway, which, if things hadn't been different, could well have been like the Stockton and Darley. But they were laid around some collieries near Sheffield. And as it says at the bottom, they weren't well received by the local populace. And this is the record of the son who talked about his father's work in laying those tracks. It said, a riot ensued, the railway was torn up, the coal stave burnt, and the inventor, my father, reduced to the necessity of concealment in a wood for 3 days and nights to escape the fury of the populace. So it's not always been easy being a permanent way engineer. It was, people don't like change. It's threatening. Some people find change threatening. But one of the biggest changes in the early days that began to supplant the wooden wagonways was the coming of the iron industry, particularly in South Wales, in the Merthyr Tydfil area. And this is a painting of blast furnaces around Merthyr. And in fact, some of the rails used on the Stockton and Darlington Railway were made here and shipped around to the northeast. It was a major change. And the old wooden wagonways began to be replaced by plateways, where the form of rail was, as you can see in the picture here, an L section with an inside flange. The wagons were not flanged, the flange was on the rail, and they were on stone blocks. And that was a very typical form. The rails were about 3 foot long, they were cast iron, so they were quite brittle. But that was a development by William Jessup and Outram. And there are a lot of plateways that began to use this newer technology. Incidentally, that is where the term plate layer originated, from this kind of way. Going back to South Wales, around the Merthyr area, this is the Penydarren tramway, which was trialled in 1804, so 20 years before the Stockton and Darlington. And again, you can see in this quite well-known painting that the form of track with the flange deeper in the centre section, obviously for bending, and that is Richard Trevithick's experimental locomotive that ran and demonstrated on that particular piece of line. They had very short rails and cast iron. There was then a further development which took the industry away from plate rails to what was called an edge rail. And the meaning of that is obvious because of the construction of the rail, where the wheel ran, and now it was a flanged wheel, would run on the top edge of the rail. So we're beginning to get to something that we recognise more readily as permanent way engineers now. This is on the incline at name escapes me. Sheep pasture incline. Yes. Thank you, Malcolm. And it is believed that this is the old locomotive shed at the bottom of the incline. And it's believed that these pieces of rail are the oldest surviving in situ rails in history. That's the Cromford and High Peak railway. So that was the rail, and now so it was fish belly, because although it's built in here, supported on stone blocks, obviously the fish belly was to give this bending strength between the stone blocks. This is quite a famous engraving of the demonstration of Richard Trevithick's locomotive, somewhere around where Euston Station is today. It was quite a thing. It was just a demonstration about the practicality of steam locomotion, and it was just like running on a circuit. There's a ticket gate there, and it was 5 shillings for admission. I think at the beginning of the 19th century, 5 shillings was well on the money. And if you bought a ticket on one particular day, you would have not got your money back, because as a precursor to what the industry has suffered often, the engine broke the rail. Toppled over, and it was left on its side, and that was the end of that. But it demonstrated that steam power on metal, on iron rail, was a practicality. And it's quite interesting that even very early, the engineers of the day recognised that the locomotive was prone to breaking these brittle 3-foot-long cast iron rails. And it was one of the reasons quite early on why locomotive engineers went from 4-wheel 2-axle to 3-axle locomotives, to actually reduce the axle loading on the rail. We are perhaps more used to some of the consequences of that as civil engineers, because when British Rail was looking at modernising its diesel fleet, it invented and trialled this very powerful locomotive, Kestrel, but it had a whopping axle load of more than 22 tons. And really that spelt the end, but it spelt the beginning of a much lighter axle load and a different concept of train, because the HST power cars only had an axle loading of about 17 tons. So again, the track engineer has influenced the design and the production of rolling stock and vice versa. So when we go back to the opening of the Stockton to Darlington 200 years ago, we've just seen that picture. What was it like? And the answer to the question was, it was not a revolution. It was indeed an evolution, as I've tried to explain already, where it came from. And so the early track on the Stockton and Darlington was stone block, fish belly rail, 3-foot lengths, which was typical of the standard practice of the day. There are some lengths of it that survive. This is in the North Road Museum in Darlington. And there are some still in situ on the old route of the Stockton and Darlington. This is the Brosselton incline. And there's a route map. Now, it's quite interesting. One of the things I've discovered about this, and again, recycling is something that's very typical of our modern day, but it's not new, because the track form between Stockton and towards Shildon here, through Darlington, This was in the proximity of quarries, where the stone blocks were quarried and cut and installed, and they employed young boys to actually drill the holes into the stone blocks for a pittance of pay, ready to take the chair bolts. At the other end, out towards the sea, at the Stockton end, which was much further away from the quarries, the railway was actually built on wooden blocks, not stone blocks. And those wooden blocks were shipped from Portsmouth, and they were recycled ship's timbers from redundant, broken up warships. So, say, recycling, not something that's totally new. This is a famous painting too, of the Rainhill trials in 1829. And again, you'll see the same trackfall on stone block, but now the stone blocks actually have been turned. And so we have a diagonal lozenge shape for the stone block, which I think gave greater stability. Even when we were building some of the new trunk routes, like the London and Birmingham Railway, under the supervision of Robert Stephenson, Stephenson was wedded to the concept of using stone blocks. And here you can see the new line being built on stone blocks. This is the contractor's line for moving materials along the construction site. And I probably don't need to tell you, but I will say it anyway, that is the origin of permanent way. This was the permanent way, and that was the temporary way, the contractor's track. And that's where the term came from. But Stephenson was very convinced about the use of stone blocks. But getting them set was not easy to get top and line. And from Andrew Dow's book, this is a device that Stephenson developed. It's quite self-explanatory. As a cuddy that lifted a very heavy block, and guys on the other end would just pull it down and let it drop onto the ground, and the navvies would put some fine stone chippings underneath until it was level and aligned. So you can see, yeah, incredibly labour intensive for building a main line. And then onto those blocks. This is a rail chair used on stone blocks, and they would have been bolted down into the pre-drilled holes in the blocks. Here's the first of our case studies. The problem with stone blocks was keeping to gauge, keeping top and line. They were not connected between them. They were independently seated. So it was very easy for the line to go out of gauge. And there was an accident quite early on the Manchester and Leeds line, London Foot, where a train derailed on a section with stone block sleepers. It had come off something that had been relayed with wooden sleepers, and the investigation, this is one of the accidents that's recorded in that railway's archive. It's quite interesting to read the accounts of the investigations that were done way back in 1847. And by the way, the investigation normally reported within about a day or two of the accident. That's something that's changed, hasn't it? But the inspector found from the Board of Trade inspector found that the track was terribly out of gauge. In some places it was about an inch tight to gauge, in other places it was an inch wide to gauge. The chairs had sunk down into the sandstone blocks, so it was a pretty hopeless bit of track. And train derailed on it. It was heading in this direction towards Sowerby Bridge, and it went through a tunnel, came up to Sowerby Bridge Station, and a couple of the derailed vehicles then hit a structure, and sadly 2 people were killed through that collision rather than the derailment itself. So far from an ideal form of track, particularly as the railways developed. It was also interesting that the following train was aware of the derailment, crew. They alerted the local station staff and had the rail replaced where the derailment was within a matter of an hour or 2. So that's the beginnings. And then much of the 19th century was about finding our way. It was about experimenting with what worked and what didn't work. And it's quite interesting. If you can see here on the right-hand side, you've got a section of fish-bellied rail, which is, in this case, 15 feet long. Because by this time, wrought iron had begun to replace the cast iron, and it was much stronger, it was more malleable, it was less prone to breakage, and it was being rolled in 15 feet lengths. And you can see that there. And incidentally, going back to talking about George Stephenson and the Stockton and Darlington Railway, Stephenson had shares in the foundry that was producing the short cast iron rail links. But he insisted that the right material was actually wrought iron and the longer rail links. And he actually ended up in conflict with his business partner, who wanted a slice of the action. But Stephenson knew what was right. This is one of the other pioneers of the early railway days, Nicholas Wood, and he produced a treatise really on track engineering as it was. You know, we're of course all familiar with standards and good practice guides and everything, but there was nothing. All that there was discussion between track engineers on what they were doing and what they were thinking. But there was nothing really written down. And Nicholas Wood tried to do that. And you can see here a comparison between the stone block road and the transverse sleeper road. And he documented both types. One of the things that the early track engineers had to learn, and in a way it was not, it was almost counterintuitive, because a lot of the early engineers thought the more solid we make the track, the better it will be for the railway. And this I took from an 1887 paper from the Institution of Permanent Way Inspectors, the forerunner of the PWI. And he's describing how there's a piece of railway he knew on that same piece of line between Manchester and Leeds, how they actually track to rock. So you had an absolutely rigid, solid piece of track. And the thinking was that you would never have to go back and maintain it. Wrong. And as you can see there, within a matter of weeks, they had to rip it out and put it on some ballast because it was just too solid. It was breaking springs, it was breaking the rails and so on. And very interestingly, one of the learning points for the industry with the opening of the Liverpool and Manchester Railway in 1830, I'm sure we'll be aware of Chat Moss in the way that Stephenson and his engineering colleagues had to put all kinds of brushwood and so on to actually create a track bed to stop the railway sinking into the bog. What records showed very quickly was they spent almost no money on maintaining that piece of railway. So the lesson was learned the hard way, that you needed elasticity under the track, not a solid track form. So that was one of the early lessons. We looked at fish belly rail. This is a very early example from the National Collection. And you can see that the rail section is a T section. Just go. John Birkinshaw patented the rolling of wrought iron rails in 1820. And so they became increasingly well used and replacing the brittle cast iron rails. And as they've been rolled in different sections, you could roll different sections through the rollers that he patented. And we were beginning to see longer lengths. He even talked, because even then it was recognised that actually having joints between rails was a bad thing. And Birkinshaw even talked about developing rail welding to create longer lengths of rail. Not something he achieved in his lifetime, but it's interesting that he knew that that was the right way to go. So lots of different rail sections, and we're going to see some of those as time went on through the 19th century. As say that the T section, no foot to the rail, and inevitably acting as a beam that was not particularly good, but it was quite a widely used rail section early on. And this is a chair that would have accommodated it, thought to be from the Liverpool and Manchester Railway. And you can see this little notch here, and that would have been a wedge that was slid between the chair and the web of the rail to hold it firm. But as the 19th century went on, track engineers were finding they had to run very hard to keep up with the industry. So in the last 35, 40 years of the 19th century, not only was the network growing, but train mileage was rapidly increasing. Trains were getting heavier, faster, and interesting, track maintenance costs per mile tripled in those years with the increasing traffic speeds and intensity and so on. So there was always a challenge for permanent way engineers to keep up with the way the industry was developing. The T-section rail soon began to be replaced by something with a rail foot. And this is a double-headed rail. But there were other rail sections being looked at, experimented with, particularly by, know quite how to pronounce his name, I suppose it's Vignolles. He was a great opponent of what we know today as flat bottom rail, with a very significant rail foot. In the late 1830s, this was used in places around the network, but not commonly, not so commonly in this country. In continental Europe, in North America, the flat bottom rail was used very extensively, but less so here. Again, you can see different versions of that. But one rail section that did come into very widespread use quite early on was Joseph Locke's double-headed rail. He had quite a conflict with Robert Stephenson, who was still very much wedded to the old style of fish-bellied rail on stone blocks. But in building the railways up to Crewe, the Grand Junction Railway, Locke used very extensively the double-headed rail. So you've got the foot is exactly the same dimension as the head of the rail. I'm sure I don't need to tell you that. And it became very, very widely used for very many years in this country as the standard form of rail section. I found this in a 96 PWI paper, which just very interesting title, Defects and Perfection of Permanent Way, and it talks about the various things that can go wrong with track and what you need to focus on. You can read it for yourselves, and I'm not going to read it all out. But what it reminded me of when I read that for the first time was, and I've adapted the child's rhyme, because this to me sums up permanent way engineering. And that's really what it's all about. So we're talking about double-headed rail. And the second case study I just wanted to mention briefly was at Hatfield. I discovered, looking at the Railways Archive schedules, that there have been 23 accidents at Hatfield over time. 3 of them have been permanently accidents, all broken rails. And of course, we know the third one. But this was the first of those, and it happened when a gang was actually working with a double-headed rail. They were turning it into S&C. Train came as they were in the middle of their work. The rail broke. One passenger on the train, which obviously derailed on the break, was killed, but so was one of the platelayers who stood back, and he was killed by flying debris from the derailment. And I found this statistic from a PWI paper that in 1880 there were 1,837 recorded rail breaks, of which the majority were iron, and many of them double-headed rails, and more than half of them had been turned. Now, the problem that was debated very widely in the PWI papers and in section meetings was that it wasn't worth turning the rail, because by the time you turned it, the foot was already damaged and it didn't create a good running surface, so it was not economical to do. Back to that in a minute. I don't think this necessarily suggests that double-headed rails had any inherent weakness as such. It's probably just that in terms of the number that were broken, but just probably illustrates how much double-headed rail there was in the network at the time. But here's a paper, and it's as late as 1887, and it's by one of the vice presidents, and he was still arguing in the forerunner of the PWI that actually double-headed rail was more economical than bullhead rail. And his argument was that if you turned it early enough, you could get more wear out of both sides of the double-headed rail than you could out of the single head of a bullhead rail before it's worn down sufficiently for the wheels to start rubbing on the tops of the chairs. But he suggested that to do that, you needed to turn the rail every 2 to 5 years. And he still argued that it was economical to do that. And the paper is very interesting because you see some of the response of other people who'd heard him read that paper, who were, shall we say, of a different view. And it's not a view that prevailed. And here's a section highlighted from that piece that I talked about earlier on. The rails may not be stiff enough to prevent undue deflection. The engines and carriages will oscillate, and rails and road are rapidly destroyed. And as I said a little while ago, the challenge for the permanent way engineer was to keep up with the increasing weights, the increasing speeds, the increasing intensity of traffic. And that was illustrated very well by our third case study, also on what we know today as the East Coast Main Line at St Neots. This was, again, a broken rail and a derailment, and with fatalities. I can't remember how many in this instance. But apart from the fact, I think these are very elegant engines. The point I'm trying to illustrate here was this was the motive power of the day. One of these Stirling singles was at the head of that train that broke the rail at St Neots, and you can imagine what the axle loading from those would have been. So the track always struggling in a way to cope with traffic levels and can't make enough at that point. And here's something that we all ought to recognise as well from that paper. Ballast of an inferior class and drainage out of order causes a very bad and defective road. Well, we do know that, don't we? Richard, can I just ask you to pass my green rucksack home? I've got a prop here that we'll come to in a minute. We're talking about ballast and formation, and there's some. Thank you. That's great. There's some fantastic stuff, and I can. If you're at a loose end, we've got an hour or two to spare. I thoroughly recommend that you go on the PWI website and go into the historic journal records and just look at the variety of what's available and try and read some of those papers, because they give some fantastic and very interesting insights. And again, words from one of the papers. This was an inspector. It was 20 years ago. Any rubbish was on many lines, thought good enough for permanent weight ballast. I've known more than one engineer and inspector object to really good stone ballast on the plea that it was too hard and likely to damage the sleeper. And you find in the pages of the PWI journal, there was lots of argument about what was good ballast. And many people thought that what we recognise as good ballast today was not really the right thing to have. All kinds of stuff was used: cinders, gravel, sand, burnt clay, some of which, as soon as it rained, just turned back to mud, basically. So there were all kinds of materials used, but not everybody agreed with that comment, and there was quite a lot of controversy over what he said. And I had to put this in. It's not perhaps quite where we're going, but this was again another paper about widening formations and the economies that are being driven by the railway companies for cheap widening. He's quite a controversial character, this Oates, so we'll come across him again. But the old tin pots and kettles, come hay, come sawdust, come almost any and every known substance was just thrown into widening railway embankments. So the quality of railway construction was not always perhaps as good as we like to imagine it might have been. So ballast. Before we move on from ballast, we are, of course, familiar with quality control, very tightly specified material requirements. A little prop here is a piece of track ballast. And I found a reference to an early materials test for track ballast. And it basically said that it shouldn't be larger than a man can put in his mouth. So I don't know whether anybody wants to participate in that. I haven't tried it. Anyway, we move on. So we looked briefly at ballast, and this, I need to go to Canto, and there's no way I can explain in a lot of detail many aspects of this, but we've talked about sleeper types, and there was again a great deal of debate during the 19th century about the merits and demerits of transverse sleeper track and longitudinal sleeper track. Brunel's bulk road, and this is a particular type of rail section that was developed to sit on triangular longitudinal timbers. This was Brunel's design for the bulk road, complete with timber piles, because again, at the time, this was in an era when people thought that the more rigid, stiffer the track formation, the better. And he soon got rid of those piles. But the longitudinal timber track survived for many, many years. Even after the end of the broad gauge, the Great Western was still running on a lot of longitudinal timber with transverse transoms here to hold it to gauge. I like that picture a lot. And I often wondered, well, how do you maintain the top on longitudinal timber bulk track? And then I found this picture and I thought, oh yeah, well, you can do it. I don't know whether you do this at Didcot, Richard.
We have actually done that, yes, but it was about 40 years ago.
But the interesting thing is, again, a lot of debates in section meetings, and it stands to reason that unless you're very careful doing that, you can easily put the track out of gauge because you twist the longitudinal timber. But there are many people who spoke in PWI meetings about the benefits of this and the fact that even in the late 1890s, the Great Western was running heavy and fast trains very smoothly on longitudinal timbered track. You'll recognise
I do.
This, the layout of Didcot. And one of the advantages of that was that the rail section could be much less than on the more conventional transverse timbered track, much lower, much less metal involved, and jointed very easily. So going back to our reference, if the joints of the rails be not such as to make the whole line resemble a continuous bar. We need to think a bit about joints. And this little section here, sorry, I keep all compressing. The problem of the rail joint. Now, at the beginning, you can see these cast sections had a little foot, and the opposing end would slot into that recess and be pinned down. There was nothing actually to hold the rail heads together, but it sort of went together a little bit like Lego, I suppose. That was early jointing. And I love this picture. It was a picture I took 50 years ago, and I was actually interested in this. And it's only when I looked back at it, I saw this little lad here, and he was obviously fascinated by the rail joints. And that was in 1975. I wonder if he's a Fernway engineer now. But maybe he was wondering about how you got rid of the joints in China. Again, you had this kind of tongue arrangement for holding the heads together, or sometimes rails were scarfed and then sat in a joint chair. This was before the invention of the fish plate. This is a chair for a scarfed joint, and you can see here that the wedges would have forced a ball actually onto the web of the rail to hold it tight and in place. Won't go into a lot of detail. This was a Stevenson patent for a joint, and I think the point to make about this is just look at the complexity. You've got all kinds of bits that slot in, and then you've got wedges, and you've got chisel heads that go into the recess in the rail. So incredibly complicated. All sorts of jointing mechanisms were tried. But it wasn't until 1847 when the creative engineer William Adams invented and patented a fish plate. Again, there were no bolts here, they just held the two rail ends together. And then a bit later on, the Midland developed the concept of the fish plate, and quite common in use was the one on the right, the clip fish plate, which went under the foot of the rail. Also, you had these continuous fish plates, which were themselves bolted down to sleepers. I put this in because I have no idea what it is or where it's from. It's from the Midland Railway, it's from the Settlement Carlisle, but the rail section is embedded in a timber block. So if anybody got any ideas why that may be, I don't know. But so we've been through the 19th century. Talked a little bit about fish plates. Steel rails came into use. The first steel production went to crew for rolling into rails in 1860 and were installed. Some rails were installed near King's Cross in 1862. And then for the next 12, 15 years became more and more widely used. But I just want to talk about a little bit about sleepers. Um, the early wooden sleepers were quite often these trunks just sawn in two, the flat edge face down, and the rails fixed with spikes to the rounded top. I put this picture in because it illustrates the problem. The picture was taken in the early days of the Western Clevedon and Portishead Railway, which was an eccentric railway which was always broke. They started building it in 1887 between Western and Clevedon. Finally opened in 1897, 10 years later. But that was after the Board of Trade Inspector had actually rejected opening. And one of the reasons why he rejected it was that in the 10 years since they started construction, most of the sleepers that have been put in and rotted. So sleeper longevity was a serious problem, and it gave rise to all kinds of experiments in the industry. This kind of rail section where the flat wings sat on the ballast, buried down into the ballast, and this bore down on the ballast, and rails of this type were installed, I believe, just outside King's Cross for a while. And that was because nobody could rely on the quality of timber sleepers. And the Barlow rail, of course, with transverse ties, but that also was to get around the problem of poor quality timber. And even quite early, steel sleepers were being trialled. 1863 here, 1979. And Francis Webb, very well known as a locomotive engineer at Crewe, but he developed some steel sleeper track, which was quite successful. So there are various examples of that in the 19th century. But it was the creation of the creosoting method which really made a huge impact on our industry. And there's a paper, again, this is one of the fascinating things about, really practical papers, a lot of practical advice on even how to stack timbers in the yards before you creosoted them. This is Hayes Timber Yard. You can see the main line bridge back there. And generally, the big railway companies would have had timber stacks of around about 300,000 sleepers, and they would have been there for a year before they were ready to be creosoted. And of course, the invention of the creosoting cylinders, where they were run in and then the creosote was injected under pressure into the timbers. So that really did transform the nature of track towards the end of the 19th century. Let's go back to the various types of rail section that were tried, and I've showed you a few examples of that. The Midland was quite progressive in trying different things. Can't really see the detail of that, but it fascinated me. It's dated 1890. I'm not sure its provenance, but it's a very interesting hand-drawn record of different types of track going right back to the beginning. So that heavy-headed rail of the Midland, towards the end of the 19th century, by the end, we were coming towards the point where all these different rail sections and the like, some more successful than others, but they were beginning to converge at the end of the 19th century into what we now know today as the Bullhead rail section. And that was one of the first British standard specifications published. And it's interesting that the Engineering Standards Committee that oversaw the production of that standard had a great deal of PWI representation in that committee. And it was really trying to bring together best practice from all the various railway companies. And it ended up with the standard specification, the BS 11 specification for Bullhead rail. So that's how we ended the 19th century. And it's a very quick canter through some of the highlights of the 19th century. And we began the 20th century with probably the closest to a standard form of track, standard specification, bullhead rail, transverse creosoted timbers in chairs. And in a way, that form of track then served the industry well for certainly the first half of the 20th century. After all the change and the experimentation and the innovation of the 19th, we were in a fairly stable position, I would suggest, in terms of track design. But that's not to say a lot happened, and I'm going to whiz through this very quickly, conscious of time. But there were trials with steel sleeper track. And obviously, some of the big changes of the 20th century were concrete sleepers, flat bottom rail, mechanisation, increasing mechanisation, and then later on, continuously welded rail and so on. Just touch very quickly on some of those. In the 1920s, it was the Great Western who trialled a lot of steel sleepers. Most of the other companies dabbled, but the Great Western did it in quite a big way. That was in the 1920s. And then the two companies that were probably more at the forefront for permanent way development were the LNER and the LMS. And the LNER, particularly in terms of mechanisation, introducing the Morris track layer in 1930, which radically changed the nature of track renewals. And I thought you might be interested in seeing this picture. This is a track laying machine from the United States, going well back into the 19th century. But the principles I'm sure you can recognise from renewal trains, where the new sleepers are coming along at the top, then dropping down and being manoeuvred into position by hand with the rail being clipped up behind. And there was a general view that that was great for the States and the long mileage of new railroads were being built, but it would never work in this country. But of course, things have changed. One of the influences on track design was the war, the Second World War. Not least because some of the traditional textiles were quite difficult to get hold of. I think the wood for the sleepers basically came from the Baltic. It was pine and fir. So that was difficult. So a lot of companies experimented with, going back to the early days, with not stone blocks now, but concrete blocks. And then even in the middle of the Second World War, the first installation of pre-stressed concrete monoblock sleepers, setting things in motion for what subsequently became standard. That was in 1943. And we were still very much in those days into manual track maintenance. But that too began to change with mechanisation. And the first Matisse dampers the first one was delivered to the LNER in 1947. And within about 12 years, I believe, what was then British Rail had over 100 of these. And that was before Placer came on the scene and started marketing their own version of these. These were they weren't self-propelled, they were hand-propelled by the gang. So they were very rudimentary, but they quite radically changed the nature of track maintenance and packing. I mentioned Hatfield. This was the second of the Hatfield accidents, and we're sure very familiar with the star crack problem at bolt holes, and that was a derailment in '66. And of course, perhaps much better known, more notorious, was the Hither Green derailment in 1967, which I think killed 69 people on a broken rail. But as the industry moved forwards and started to install continuously welded rail, which BR began to embrace in the late 1950s. And this is an interesting chart because it shows that in 1969, there was a very high incidence of track distortions, both on jointed and CWR. But it was so serious that a number of derailments in the summer of 1969, which was a very warm summer. And it got so serious that people were asking questions in the house. You know, is this form of track safe? Should we be using it? And there was a very rapid inquiry into the nature of continuously welded rail, which reported very favourably if it was properly installed and properly managed and maintained. And it was very interesting that around the same time, if you look at the mileage of CWI that Germany had, West Germany then installed, we were playing at something that other countries had embraced long before. So there was this crisis of confidence and a very interesting report, very quickly produced, and BR quite quickly developed a response regime to set those concerns at rest before the warm months of the summer of 1970. This is something else I put in, I think, because it has influenced what we do as an industry. And this was the broken weld at Bushy in 1980, which I think I'm right in saying completely transformed the way we do asset management, the records we keep, the training, the certification of track welders and so on. But all through this, going right back to the beginning of railways, we've often learned the hard way when things have gone wrong. And if we investigate thoroughly, then we can put things right and learn the lessons and move on and improve. And that was certainly the outcome, I think, from Bushy. And then one of the changes in the 80s was the introduction of loose sleeper relaying. I love that picture. I think we did it quite right. Of course, it wasn't always so permanent, the permanent way. There's a World War I picture of a track laying gang. I don't think we should ever pass the panels over the head. But probably considerably so for them being in the trenches. I can say to that one. And this is a fascinating bit of permanent way history. This is in the Narrow Gauge Railway Museum in Thames in North Wales. These are rail sections from some of the quarry railways, on the galleries in the big quarries, where the rail was very temporary and it could very easily be taken up and moved ahead as the workings moved ahead. And you can see the very simple chairs. The rail was a bar that just slotted into the chair, and the workforce in the quarry could relay the track very quickly. So there's all kinds of history to this. So we're doing all right for time because we're coming to the final section, which is just looking at the life of the play there. We've looked a lot at track form, the lessons that have been learned, the things that have gone wrong. Let's have a look at the life of the trackman, the plate layer, and explain the origins of that term. And I've called this section Lives on the Line, and I've been asked twice where this photograph was taken. It's a photograph that I found in a magazine and got permission to reproduce and use in this presentation. This is the permanent way maintenance gang, I think, at Dauncey on the main line between Wootton Bassett Junction and Chippenham, probably sometime during the First World War. And I said, the form of track hadn't really changed that much in those areas. And again, a very typically dressed permanent way gang with the caps or the trilby hats, the waistcoat and the watch chain and so on. You find many pictures of permanent way gangs dressed like that. This is I think, the earliest known drawing of permanent way staff, and it has been commented that they were sitting down. They'd obviously been opening up some track, so some ballast, and incidentally, you can see here, I didn't say it earlier on, but there was a lot of controversy about how you ballasted track. There was a widespread view in the 19th century that you should ballast right up to just below the railhead. Of course, in the days when you horse-drawing wagons and carts, you needed that firm footing for the horses, but you didn't obviously need it with steam traction. But it was quite widely argued that that was the right way of doing it, but it hid everything. But that's obviously what was going on there. And of course, for a long, long time, permanent way work was incredibly manual. At least we were doing some reballasting. And still manual. I think that's a big cot. Looks like it to me. That's the
Morton Yard.
Yes, I think it's just west of Morton Yard. So very manual. And okay, over time, permanent way staff had various devices and inventions that made their work a little bit easier, but it was still really very manual. Some assistants, certainly if you were senior enough to be an inspector. But this is, again, a very typical picture of, could be anywhere really, of a wayside station somewhere on the network, platform staff, your one trackman there, probably in the middle of an inspection, walking his length. Again, you know, the waistcoat. Very typical scene of much of the history. But then I found, and we've come across Mr. Hopes before, and then I found another paper by him in the PWI Journal, who was talking about the training and the position of the plate layer in the rail industry. And he was comparing it with all the other grades in the other departments, all of whom had some kind of promotion prospect. They could work hard, they could be promoted through the grades, be they platform staff, engine, rolling stock, operational staff. It didn't exist, is what he was saying, for permanent way staff. No sort of systematic training exists. The only branch of the service still working, as you might say, by rule of thumb. And he suggested that there needed to be proper structured training, examination, length of experience before promotion came. And then at the end, there's really barbed comment. If we did that, we'll produce a better type of man, of course, that was the language of the day, both mentally and morally, than the average we have at present. Didn't mince his words, did Mr. Hopes. But it was, I think it's a fascinating insight into the way that permanent way was in the early years of the 20th century. And there's another fascinating paper by Mr. Rolfe, Mr. W. Rolfe, who was a great Eastern Railway plate layer and was in post for over 61 years. And this is at the end of his career as he's reflecting on how he started. And his conclusion was that life today is much better than it was at the beginning when he joined. And he was saying, you know, there was no overtime, there were no cabins or huts. Plate layers had to make their own, maybe they dug a hole in the ground. That was it, that was the welfare. Of course, it's very interesting that we are now in a world where we no longer have length gangs, and people are actually trying to protect and preserve some of the line-side huts and list them because they're part of our history, which are rapidly disappearing. This is on the settled Carlisle. So no rose-tinted safety goggles about how life was as a permanent way man. Um, and things were so difficult for a lot of railway staff. And this is something else. So, people didn't mince their words always in PWI papers and discussions. I love this. The paper which our secretary has written on this subject of the Death and Benefit Fund, which was under discussion at the time, is very inadequate, not likely to obtain much support, at least from the younger members. It's crude and unsatisfactory. And this was on record in a PWI meeting. So it could be quite sparky at times. But the interesting thing was that the PWI recognised that there was a need for some kind of support for its members as they got either towards the end of their working lives, or indeed, if they were unfortunate enough to suffer accident or worse, their dependents. And there were lots of concerns about how dangerous it was, and of course we recognise that. This was from the Great Western, and it just cited some of the typical things that could happen to a plate layer. Obviously, being knocked down, that almost invariably would end in a fatality, but all kinds of other things that could go wrong and cause injury, or somebody to be maimed, if not worse. And I just wanted to mention this project, which is ongoing, the Railway Work Life and Death Study, which is a joint venture between the University of Portsmouth, the National Railway Museum, and it's an archive facility in Warwick, I think. And they've got a joint study delving back into records of how it was to work on the railway, not just on the permanent way, but on the railway in general. And this data here is something they published between 1911 and 1915. And each figure here represents 100 cases. So there are about 7.5 blacks. So that represents about nearly 780 fatalities. And these are injuries, 3,152. And you think, well, that's a heck of a lot. But this is a trawl of the existing known records. And if I tell you that actually only 3% of incidents were investigated and reported, that represents 3% of what was really happening out there on the ground. And okay, they weren't all track staff. There were operational staff, drivers, shunters, all grades, all in the industry. But I just picked this out of some of their data. In 1900, and bear in mind, this is a tiny percentage of incidents that was recorded and investigated. In 1900, there were 38 recorded accidents to track staff. Nearly half of them were fatal. And 7 were life-changing, by which I mean amputations. So it was incredibly dangerous. And it wasn't until 1900 that the Board of Trade thought we actually need to introduce some regulations to require the railway companies to appoint lookouts to protect the staff working on the line. And that was introduced in 1900. But it was left to the companies and to the gangs themselves to decide whether or not they were going to appoint lookouts. And one of the incidents that's recorded by that study was a terrible accident just outside Bristol in 1921, where a gang was working on a misty day. They were run down by a train coming off the branch line from Clifton. It was only doing 15 miles an hour. They didn't hear it coming, and the driver didn't see them. And it ran the gang over, and 6 people died, including, as you can see, people who doubtless had survived the trenches, and they met their end on the track. So, a huge problem. And one of the companies that led the way, really, on this was the Great Western. It created the safety movement, And there's a lot of talk about, it's all very well to take your staff into a hut if it's raining or snowing. Take them in and you read the rules. But the rules are unfathomable, or they certainly were then. And what it needed was a much better way of communicating and explaining. And to the Great Western's credit, it did that in the safety movement of the 1920s. And it produced these booklets with gory pictures, but actually giving you examples of how to behave and what was safe and what wasn't safe. And this was really the first time this had happened in the industry. And lots of examples, you know, how often are accidents caused by somebody stepping out of the way of one train into the path of another, or coming from behind a vehicle. So it was very practical, and it had an impact. There's another example there. One of the other things they did was produce these little coins, these little discs, and they gave them to staff to put in their pockets. And it was like a visual reminder, because you felt in your pocket and you pulled this out. Is it safe? You think, oh yeah. And it was just a way of stimulating thought about what you were doing. So we almost at the end. I think that's a great picture. I wonder how much track there is like that on the network these days.
Don't step on the shoulder.
I can't see any bubbler. Look how tiny the shoulders are. Yes, the path, the walkways, fantastic. When we had length games, of course. And the museum at York sent me some pictures of some cups and trophies and medals, which were awarded to the prize length, the length best looked after. This was from the northeastern area of the LNER, and staff would have been issued with this little medallion as a recognition of a job well done. I love this comment. When the retiring PWI president in 1906 was the journal is full of interesting stuff. If you start anywhere, I'll suggest 1906. It's almost every page. Wow, that's interesting. This is what he said when he left. Another point I would draw attention to is old material of all sorts left about the line. It gives an untidy and insecure appearance, and I would strongly urge all inspectors to see that old sleepers, rails, chairs, etc. are cleared away and properly stacked at a safe distance from the main line until they can be fetched away to the district depot by the ballast train.
Yes, that's yeah, right.
Did we learn?
No.
So, I hope I've showed you that over 200 years since the opening of the Stockton and Darlington, we have indeed come a very long way, and a lot has changed. Not just with materials and methods, but with people and the nature of the work that form our industry. It's not an evolution which is finished. It goes on, of course, endlessly, with modern track forms, for example. But I thought that the best way of concluding was, again, another quote from 1906 from the same man, Walter Rolfe, as he thought about 61 years of experience. And to me, this is the perfect way to draw this to a close. I would like to point out, for the benefit of the young members, that much progress has been made from time to time. It therefore lies with the present generation to continue this progress, not only in their methods of dealing with the knotty problems, but also their status in the railway world for which the Permanent Way Institution was founded. And I can't think of a more appropriate way to draw to a close a very quick summary of 200 years of the evolution of railway track. So thank you very much.
Well done. Well, are there any questions arising from that? You mind if I start?
Yes, carry on. Well, it depends what you're going to say.
Well, that's it. It's very difficult to pick things out of the amount of detailed stuff that you put over to us tonight, Colin, but I'll go right back because I was brought up in a little bit called Little Eaton, just north of Derby. And we had a gentleman that you had mentioned earlier on, Outram, who had a tramway which ran from the Derbyshire coalfields in the Ripley area of Derbyshire down to the terminus of the Derby Canal, which is at Little Eaton.
Yes.
And the Ripley Railway, which followed, ran over part of that tramway. But there was a section in Little Eaton which actually still exists, which was called the Gang Road. That's what they used to call it, and it ran parallel to the railway and ran to the canal basin, and just near Little Eaton Junction on the main line, on the Derby Federal main line. But for many years, we used to walk along that piece of railway, which is back in the late 40s, early 50s, and there was still a lot of the old stone blocks still in place along that. And people just used to walk along them. It was interesting about where they were, but it was real history because it was from about 1780 when it was first put in.
Yeah.
And I paused for it, of course.
Yes.
Didn't get superseded until they built the actual road. Outram had done a number, apparently, of similar gang roads.
He did.
You know.
He did. He's not prolific.
Anyone else? Go on then, Rodney. Well, one of the slides you showed rather surprised me. That was the extent of CWR as compared with jointed track. Now, I moved into Peeway section, I think it was 65, 66, and we were starting, I think it was called the Accelerated Programme of CWR.
Yeah.
And we started at Maidenhead and carried on. But I don't remember any significant extent, maybe the odd length or two of CWR in the 1961-2 era when I was training on Peeway. The extent that you've shown quite takes me aback. But the question I've always had is, how was it justified to suddenly start relaying en masse? And I'd always thought that it must be because of the number of broken rail joints. There was one serious one at Slough, I remember, don't think I ever saw it, but I had always thought that was the way the finances were justified. And I think what you've shown confirms that view.
Yes, I think it was reckoned. I mean, the BR board adopted CWI as its standard policy in 1959. And it was always recognised that, obviously, from a safety point of view, the elimination of the rail joint as far as possible, but also some of the other spin-off benefits. You know, you increased rail life, you increased wheel life. The smoothness of the ride actually reduced operating costs and fuel consumption costs of traction. So there were lots of known benefits of CWR. So yes, it was a policy decision in 1959, and I guess it was rolled out fairly quickly thereafter. Yeah.
But would you agree, Colin, that 1959 is right, but the real impetus for it was 1960 to 65.
Yes.
With the electrification of the West Coast Main Line.
Yeah.
All the jointed track on the West Coast, on the fast lines, not on the slow line, but on the fast lines, was taken out in that 5 years.
Interesting.
Between Euston and Crewe.
I haven't seen a split of track mileages by route, so that's an interesting point.
I've got a question from home here from Jordan P. I don't know what his other name is, just says Jordan P. Do you want to ask? Jordan, you still there? Do you want to ask your question over the air?
Apparently not.
No. Seems not. Okay, but his question was.
Can you hear me?
Oh, he's there. Go on. Say again.
Can you hear me okay, yeah?
Yeah,
Um, when was the use of longitudinal timbers ceased
it's a longitudinal.
in the earlier days? If you know what I mean.
That's a very good question, and I can't put a date to it. But certainly it was still in widespread use up to the end of the 19th century. Post the change in gauge on the Great Western in 1892. And as you saw from a previous picture, they just continued to use the track form, but at standard gauge. So longitudinal timbers stayed in quite widespread use. And again, I imagine were only replaced gradually as track renewals came along. So they must have survived into the early years of the 20th century for sure.
Well, there's still some on bridges used.
Yes, in special locations like long timbers on bridges or stations, for example, in Paddington. But out on the main line, I think they were still quite widely used.
Okay, thank you very much.
High Wycombe, there's a picture at High Wycombe of relaying. My impression is that as the track just simply got to the point of being ready for relaying,
Yes.
where then they substituted OO, the Great Western Standard of the time,
Yes.
across the track.
Yeah.
Some of it, apart from obviously bridges above, but there was a siding on the upside of Castle Carey was in true bulk road until the 1960s or so.
Yeah. Yeah.
Lasted a bit longer.
I came across a very interesting comment in one of the papers that on the bulk road, one of the requirements, the skills that the permanent way inspectors and gangers needed was carpentry.
Yeah.
I didn't think about that, but it was a requirement. And it was said that it was easier for a permanent way man to move from maintaining bulk road to cross sleeper track. And if you put somebody who'd grown up with cross sleeper track and asked them to maintain long timbers, they would have been all over the place.
Matthew, I've always forgotten your name, Anson.
I've got a photograph of Stone Railway at Haytor on Dartmoor, which is it's stone, it's S&C. You didn't mention much about S&C.
No.
How was plate railways made into S&C if they were? Did you have stone blocks on S&C as well?
I think so. And I think it was just a very simple movable tongue. No, I deliberately didn't touch on S&C. I should enough material and didn't start delving into S&C. But I think it was just a very short movable switch tongue.
Dick, you got it.
Yeah, there was a considerable length of bulk road still in place in Fishguard Harbour. Probably 300 yards of it in the early 1970s. In the siding alongside the cattle areas. That's interesting. And I often wonder why that wasn't offered to Didcot, for instance.
That's interesting. The Great Western didn't extend to Fishguard Harbour until about 1906. So they would have laid that in then.
Yeah. Second hand probably.
Yes,
It was a bridge at Oxford.
yeah, it would have been. Yes.
And also there were quite some significant lengths of CWR on the East Coast Main Line in 1960, when I travelled up to York to spend a week before leaving school, short works course on with the York Civil Engineering Department. I was fascinated by the lack of people back from never been on a lot of track. On the other thing as well is the Western still had a price length scheme in the early 1960s, because on the training scheme we were taken to look at the price length at Wootton Rivers on the Parks and Hunts work by the then my advisor, Mr. Godrich, and everybody Anybody old enough to remember that? So it was still in use, and it was taken to, this is how an excellent piece of main line should be, or beautifully kept cess walkways.
Yeah.
Perfect tire showers, alternative track, wasn't it?
Oh, hang on, thank you, Darren.
Yeah, but it's just a quick one on, you showed that picture of the mechanised tamping.
Yeah.
And the stillage rails, the sides
Yes.
that you spill on. So in London Underground, I used to walk the Central Line quite a lot. There's about 3 or 4 of those still there today in the cess with the rails. Flick over, push it over,
Yeah.
bring it on. And they're still, still in existence, haven't been taken away. Who knows how old
They
those
still use the tampers.
Matisse came in there, didn't they? Yeah. They still got plans for Matisse, but yeah, but it's still, you can still see the stitching rails and the beams, yeah. Obviously not maintained, but yeah, so
Yeah,
it's
it's-
still
there's some
existence.
fascinating clips of the film in a longer version. So I could show it, but I think it's Fast Night. Showed one of those early tampers being run onto the track off the signal tracks and then pushed by 4 guys down to the work site, and then the operator is sitting there in his own cab, sort of doing this with their handles, just dropping the times.
Yeah.
It's very educational to see how it was.
Okay, David, we'll make this the last one because time is pressing on, so.
Is slab track a good idea
In its place, yes. Yes.
at its cost?
I am not sure that anybody has ever really done a truly effective cost benefit analysis. Yes, it's expensive, but it should, in theory, reduce a heck of a lot of ongoing maintenance costs. And of course, it is being, I think, quite widely used on HS2. So for high speed, where you obviously need the tight tolerances, it's the ideal solution. It's also a very good solution for creating gauge clearance in tight spots. So,
Can I just make a comment on that? Because there's another aspect of this thing. I've seen this argument many times. From a business perspective, the great advantage of ballasted track is that if you want to change the layouts to suit the business prerogative, it's very easy to do so. This is often forgotten, in my experience. I know in specific locations, slab track is very good, and of course tunnels and things, and it's also good on high-speed lines where you know they're never going to alter. But when you think, supposing we put slab track in 100 years ago, look at a huge cost we've had every time we're remodeling anything or doing this or that. And this aspect of the changing track, ballasted track is really good from a business perspective. I just put that point of view because we tend to think of things from an engineering point of view only.
yeah.
Okay, thank you for that. Right, I think, say, time's pressing on, some people have got trains to catch. Thank you, Colin. There were pictures on there that I've seen lots of pictures of, but never had an explanation, so I've learned a hell of a lot tonight, so thank you very much for that. Malcolm, please could you do the vote of thanks?
Well, it's a great pleasure to do that, Colin, tonight, and I knew this was going to be a good talk tonight. I knew this would be a proper 200 years of what's happened since the Stockton and Barrington and where we are now. But there's 1 or 2 threads we can pick up from this, and a lot of it is because of the PWI. You've shown various comments from people, particularly back at the turn of the 19th and 20th centuries, in various permanent way documents and so on, and talks that were given. But if you look at where I find those sort of things to be of real interest and real importance, and what the PWI has actually done for the railway and the permanent way in all its forms over the years, if you read some of the original Permanent Way Institution textbooks rather than the ones the ones that are available now are fine, and nothing wrong with those whatsoever. But read some of the ones probably from the 1930s and look at the practical knowledge that was being put about to people in those days. They really were. Those sort of comments that you saw, that you put on your presentation, it comes out in every page on some of those things. And these were not just permanent way inspectors and people from the technical office and so on. These were people from what you would call the lower ranks, and don't do that in a disparaging way, but in from the lower ranks, who were encouraged to come to PWI meetings. That's where they learnt about things, and they were encouraged to talk about it from their own experience as well. So we have done, I know we might put some brickbats as far as the PWI are concerned now, but most of what the PWI has done since 1884, since we were put into motion, has all been good and to the benefit of the railway. It really has. Now, if there's one thing that it does show, is that it's a personal thing, this, I suppose. We talk about the permanent way, and we talk about all the things that go with the permanent way, and that's the ballast, the formation, earthworks, drainage, everything else that puts a track there to run trains on. If we can't call that the permanent way institution forever, we always have. Why we can't call it forever, I just do not know. Anyway, that's just a personal view of the thing. I just want to say a couple more things as well, if I will. Going back onto CWR, and this bears out about rigidity of track and this sort of business, and what we need to do. The first lot of CWR that I was actually involved in putting in a very small way, but at least I was on the site, was in 1958, when the district I was working on at Derby, we put in our first section of CWR on the Hope Valley line, on the Door and Chinley line, what's now the Manchester to Sheffield line. And just as a matter of interest with that, we did know that we had to do the reballasting with it. So we did, using drop skid shovels to do that. And we de-stressed it, going back onto things like showing in 1958 that were actually a couple of distortions and so on, so to cover it, even though there was only 112 miles of CWR on that time. And the de-stressing that we did, the method used, and this is quite interesting really, was that the CWR was purposely put in during the early days in June, and we had to get the de-stressing done and the whole thing fastened down by 10 o'clock of a June Sunday morning. And it was de-stressed by putting some plastic pads, BJB fastenings, plastic pads on, and we rolled it along with, we've got side rollers into it as well. We rolled it with a Class 8 280 locomotive and measured how much it moved along as the temperature increased. And we got breather switches at either end of it, but we didn't know that we had to reballast it. One further point with that about the rigidity, which was mentioned a lot in your talk, was that going back to the West Coast Main Line, putting all the CWR in, because we hadn't got the right machinery or the time and so on to do the reballasting, concrete sleepers and CWR were put in on the West Coast Main Line by just opening the track out, by no reballasting with it virtually at all, because we hadn't got the machines to do it. Then we put Class 81 locomotives on it and thumped it to hell, and it all went to pieces very, very quickly. So you don't want a rigid system. You do want a system which has got some resilience in it, which is why the resilience is put in with pads and this sort of thing when you put slab track in. Otherwise it would be too rigid. And of course the formation needs to be prepared in exemplary fashion before you put slab track in, which is why it's fine for new track, but not much good for existing track. Anyway, Colin, you have given us an absolutely superb talk tonight. Really good, this one. I shall look forward to Richard's write-up with it. It's one of these things.
Challenge there.
Come on, you do a good job with that, you really do. And that will set the seal on what's been a good evening. Thank you.
Thank you, Malcolm. Richard, next meeting, please.
Ah, right, drainage. But that's after we've had a brief sort of discussion, hopefully, with our chief executive, Stephen Barber, and our past president, Mona Sahota, who you met last April or May, about where the permanent way institution is going and possible name changes, one of the final stages at this juncture. So that's something that's very important, as we all appreciate, and I hope we'll all come along and take part. The drainage renewal, Mark Howells is giving a talk about drainage. You all know Mark. He'll give an excellent talk, I'm sure. And you can see the agenda says it's about drainage at Patchway this time. So it'll be really gripping stuff, I should think. Well, no, seriously, I don't mean that. I was thinking back to the Royal Heating Group then. But drainage, Mark always gives a lot of extremely good quality information in his talks. So I think it's been another good talk for us to receive ourselves and have available on the PWI website. Right.
Okay, thank you, Richard. Okay, that just leads me to say thank you for everyone for joining in tonight. Thank you for those tuning in from home. We had 17 at the peak. And I remind those at home, please leave Teams so it shuts down and it doesn't run the recording on for the next 17 hours. So please leave the meeting as we close. For those in the room, there is a bonus film clip to show, but it can't be shown on the recorded live thing over the air. So if you've got a spare minute to spare, we can show you that film clip.
Literally lasts about a minute.
But we can't do it.
It's X-rated.
Yeah.
So it is permanent way related.
But hang on, I just need to get close down because we can't transmit it because it's not licensed. So thank you for those at home. Turn your machines off when you leave. I'm going to leave you now so we can show this film. Thanks very much.
Thank you, Colin, from the people at home.
See you next time. Thanks.